All right, so I'm back. I know it's kind of weird that I had to stop the video, but I had to flip the direction of my video so that my left hand is actually the proper hand here. So my left hand is now in the right side. So how the left hand rule works, and that we use the left hand for negative. So if you are going to do anything with your hands here, it's kind of a bit trickier now because the direction of the video is kind of switched on me. But my left hand is going to be negatively charged. My right hand is going to be positively charged. So I'm going to pull up my left hand. Okay. Now how this hand rule works is that you put your thumb in the direction of the charge. So it's going to go downwards. And then your fingers are going to wrap around the wire, around the direction of the charge here. And that's going to be the direction of the magnetic field. All right. So I'm going to just kind of point towards me. So that's going to be the direction of the magnetic field, the direction of the curl of your fingers. So you're going to have a wire. So let's imagine that this is my wire. Is that a black line there? Let's move out of the way. My hand is going to wrap around that wire, and that's the direction the magnetic field is going to go. It's going to go this side, it's going to go around the front in that direction, and then around the back the other direction. So that's how I know that this is the direction of the magnetic field in this picture, because if I were to draw a hand, I'm going to see how well I can draw a hand here. I put my thumb downwards, right? And then my fingers would wrap around the wire, right? It would wrap around the wire and wrap around the back side of this wire. So this is my hand here. My fingers would go around the other side. So my fingers would go in this direction. They go around that way. So my fingers are wrapping around that direction around this wire. So this is the back of my hand there. It's going around the wire, so in that direction. So that's the way that this field is also going to go. So it's going to go around this direction because that's the direction my fingers are going to curl. Okay, so it's going to go in that direction. Now, the next page here describes that with another better picture. Obviously, it's a real hand. You can see that they used a left hand here. So they have the current going this way, right? This direction with my thumb. The current going that direction. The field is going to go around the wire in the direction of my fingers, around that direction. So it's kind of hard to see on this picture here, but the field is going to go over the top, down the front of this here. It's going to go down the front, and it's going to go around the back side. So it's going to go down the front, around the back side, down the front. It's going to do that nice little concentric circles. It's going to get wider. So that little demonstration that we had before, you can see that they have the circles here. So if I were to use my hand rule here, let's just reverse the current. My thumb is going to go up this time. My fingers are going to go around this direction. So they're going to go around, here's my wire. They're going to go around the back side of my wire. And you can see that the compass, when it's behind the wire, is pointing this direction. And you can see my fingers there. All right, so it's going to point around. So it's going to be around the front of the wire. So when I put the compass in the front, you can see the compass is pointing that direction when it's going around the wire in that direction. So it's going around the front there. It's going to, this side here is going to go into the page. On the other side, it's going to go out of the page. You can see that when you move this around, that's going to go pointing towards into the page. And this one's pointing out of the page. Okay, so it's going to create these little circles. You can see that this little picture here, concentric circles, they don't cross each other. They don't spiral or anything. They kind of stay where they are. Okay, so that's essentially how the left-hand rule works. Okay, it works for electron flow. That's the left hand. Now, if you ever talk about conventional current, you're going to be using your right hand, right? So everything would be going the other direction. So if I were to think about this hand, so my current In this picture here, my current is electron flow. Change my color of my pen by accident. Right. This is electron flow here. But if I were to think about conventional current, positive charge, my magnetic field would end up being the same direction. So I put my thumb in that direction. It's going to go, this would be, if I treat that as if it's positive charge, hit my wire. Okay. My fingers are going to go around down the front, just like this picture says, but you notice my hands are just in the opposite direction. So if I would put these two here, here's my left hand, here's my right hand. You notice that they both wrap around the same direction, even though my thumbs are pointing in different directions. But one is for positive, one is for negative, right? So I'm going to have to keep my video flipped from now on, just so that my hand rules work out nicely. It's going to be a bit weird for me because my hand motions are backwards than usual. Okay. So that is the first hand rule. You can see that it's being described again here for this to work. We call it the first one because there are 3 hand rules. They're not the same hand rules that the crash course video talks about. They have 3 hand rules, but the 2 hand rules at the very end, they're essentially this is the same hand rule. I don't know why she calls it 2. So in the first hand, you just place your thumb in the direction of the electron flow. This is for the left hand rule, right? And the curl of your fingers is the direction of the magnetic field in these nice little circles. So I'm just going to redraw those so you can see that this is going over the top and around the back, right? Now, I want you to stop or just pause here and just think about this picture here. Can you draw the magnetic field around this wire? I'll give you a couple of seconds. Okay, so hopefully you paused and hopefully you tried this out. So you're going to use your hand rule to figure this out. So right now we have the electron flow is coming out of the page. So there's a little dot here. There's a little wire here. There's a dot. Electrons are coming out of the page. So what you're going to do, it's going to be a bit tricky for me. So you're going to have your thumb coming out of the page. So this is going into this. So I'm picking my left hand because we're talking about electrons. So we have electron flow. So I'm going to use my left hand here. And the hands are very important. I had a student a couple years ago that said, "Oh, we could use whatever hand you wanted." And you always got these questions wrong because the hands are really important in which hand you're going to use for which rule. So the left hands are for a negative charge. The right hand is for a positive charge. So what you're going to do is you're going to put your thumb in the direction of the charge. So my charge here is coming out of the page. So my thumb is going to come towards, in this case, towards the camera. It's coming out of the page. And your fingers are going to curl in the direction of the magnetic field. So the 3 lines that I have drawn there around that little wire are the concentric circles. And I have this little picture here. You can see that my thumb is going into the page. My fingers are curling around in a clockwise motion. So I'm going to draw arrows in a nice little clockwise motion here. So my thumb is coming out of the page. Okay, my thumb is coming out of the page. Fingers are curling around in a clockwise motion. So my field is going this direction. And it just gets weaker as you go out. Remember, the rule for that is not inversely proportional to the square of the distance, it's just the inversely proportional. So that is my magnetic field. Kind of drew that kind of way out there for some reason. So let me just erase that. That's my magnetic field. And there's a bunch of these circles coming outwards, but I'm not too concerned about drawing an infinite number of these fields. So that's how we draw those. Now, I think I might have a question later on here. What if the wire was laid horizontally? I'll just draw it down here. So say my wire was drawn horizontally this way. Right? So this is my wire. And let's just say, for the sake of this question, my electrons are flowing in that direction. So they're going this way across here. how would I draw this? It's a nice two-dimensional picture. So I'm not going to expect you to draw like a nice three-dimensional loops going around this thing. So how would I draw the magnetic field above, below, in front, around this wire? So if I'm going to draw the magnetic field, I'm not going to draw loops because the way the picture is, it's kind of flat here. What I'm going to draw is I'm going to draw about how the field looks above and how does it look below. So if my current is going this direction, I wrap my fingers around, you notice that here's my wire. My fingers are going above the wire, they're going in towards the page. Right, so I put my thumb in the direction of the current, and my fingers are going in towards the page at the top there. So just to draw that out, I would draw a bunch of X's here. Okay. So that's the magnetic field above the wire. So it's going to go into the page there. It's going to go around the back side. It's going to go around the back side. And it's going to go this way. Yeah, it's going around the back side. And then when it gets to the back side, it's going to come back around the other way. It's kind of hard to see that with my elbow in the way. But it's going to come back around, and it's going to come out of the page on this side. Right? So that's what's happening there. And then when it gets to the front side again, it's going to go up and then back around into the page again, the other side. So that's how you would draw the magnetic field around the wire on a kind of a two-dimensional picture. You're just worried about what's above and below. Most scientists will say, okay, that these are going to have to connect together. So there'd be like a field here on the front side going upwards. On the back side, you can't see it, but it's going downwards. So that's what it would look like, right? Okay, let me just pause this for 2 seconds. All right, so now what happens if we put the wire into a loop? Let me just move this out of the way. So here we have a wire right down in there. Right? You have a wire that's kind of going into a nice little loop. So it's the same wire that we had before. It's just rather than going in a straight line straight up or down or straight across or in the page and out of the page, you take this wire that we had and we loop it around in a circle or any kind of loop. And what you could do with that wire is you can take that wire and you can actually wrap it around in a bunch of circles around this wire. I'm really worried about just one of those wires, just one loop, because then we'll stack a bunch of these loops going in the same direction on top of each other and hopefully create what we call an electromagnet. But we're going to use our hand rules to figure out what's happening here. So let's imagine, for the sake of this argument, this I here is electron flow. So this is my electron flow. So my electrons are flowing around the wire. Move this out of the way. In this direction. That's my current. So my electrons are flowing this way around this wire. Okay. And they're trying to do this kind of three-dimensional. You can see the X, Y, and Z axis there. So what's going to happen is let's just look at one section of this wire. And then we're just going to repeat the process for all the different sections around here. So I'm going to do this section right here first. Just that piece. And I'm going to try my best to draw a three-dimensional picture of what those loops of the magnetic field are going to look like. How are they going to look at that point? So here's my wire at that point. My electrons are flowing this way. So what they're going to do is they're going to go on the front, they're going to go up, they're going to over the top and then down behind the wire and then kind of loop back around this way. So if I were to draw that, this is going up the front, over the top, and then down the back. So my field is going to go up the top, over the front, down the back, and then loop again. So it's going to kind of look like this at that point. Okay? So up the front, over the top, down the back. So we're going to do the same thing with these other wires. So if I look over at this point over here, I've really just kind of moved the shift of the wire just a little bit. So now it's pointing kind of this direction. So my thumb is going to go this way. So it's going to go up the outside, over the front, and then down the back. Up the outside, over the front, and down the back. So this part over here, it's going to go, oops, it's going to go this way this way around this wire. So loop around that way. Okay. Now I have my wire on the back over there. My thumb is going to go this way. Let's see if I can get this in a good angle here. Okay. Still using my left hand because so it's going to go, my thumb is pointed that way now. So it behind the wire here, over the top, and then down this side. Seems like that's inside the loop. So over here, my little circles are going to be this way now. Essentially, they're just the same, right? And then over here, if I did the same logic, it's going to go this way over top of my wire, all the way around. And I could do that process all around this wire at any point. And then what I would realize is that all the time it's going over the top and down into the middle inside this. So it's going to go around the top. It's going to loop back around. And there's going to be bigger circles as you go. I'm just drawing like the little circles around here. Now, what you'll notice that is one of the questions is, where's the magnetic field going to be the strongest? It's going to be the strongest where the biggest concentrations are of the field lines are going to be. And if this kind of looped around here, this concentration is going to be a little bit stronger on the inside. So we're going to have a really strong magnetic field on the inside. The key to this is, how does that look from the side? So if I were to draw this from the side, so here's my side picture of this. Okay, so I'm looking down the x-axis. So I'm looking this way to the x-axis. So you can think of this is my z-axis here. This is my y-axis here. I'm looking straight at it on the x-axis. So if I were to draw magnetic field lines at this point, so I'm looking at this point, so I've got lines going up the front, down the back. Let me just draw that, complete that circle. So down here, up the front, down the back. Down here, up the front, down the back. The front, down the back, and these are going to go in towards, I guess they're going this way, they're going in towards the center. So all these lines are going in towards the center of this magnet. So I got these loops here, looping around and kind of pointed towards the center of this magnet. Now, what I wanted to say about this is that where are the lines coming out of? Well, the lines are coming out of the bottom of this magnet. They're going around the magnet or around the loop and coming into the top. Now, if I were to draw a bar magnet and put a north on the bottom and a south on the top, it would look the same. It would come out the bottom and into the top, out the bottom, into the top, out the bottom, into the top, out the bottom, into the top. So these are all coming out the bottom and into the top. So what we've created here, with just one little loop, we've created an electromagnet where the bottom part of this loop is the north side, just like this, the bottom part where all the lines are coming out, all the lines are coming out. That's our north side. They're going to loop back around, right? They're going to loop. So this is why they have to continue in loops. This is Ørsted's rule. They're going concentric loops here. So they're going to loop around and go into the top. So when they go into the top, that's the north side of the magnet, or south side, sorry, of the magnet, when they go into that side. And they're going to continue through the magnet. That's what they do. These are just loops, so they're going to continue through the loop or magnet and finish off the loop. So we created an electromagnet where there's a north side on the bottom of this loop and a south side on the top. So that's what we've done. Now, if we loop this around and we do the same thing, so rather than just have one loop, we have multiple loops. Okay? How do we know which side's the north and the south? So let's go back to this picture here. Let's look at creating what we call the second-hand rule. I think that's what it says here. Yeah, the second-hand rule on the next page. Let me just draw that out there. Okay, there's going to be a second-hand rule. Again, we're going to use a left hand because it's electrons we're talking about. So I just want to go back to this previous slide. So how we know where the north is for the second hand rule is we put our, now this kind of works, it's a little bit differently. So rather than the thumb being the direction of the current for the second hand rule, our fingers are the direction of the current. So we wrap our fingers in the same direction that the electrons are flowing here. All right, so I can turn my hand this way a little bit more. So I'm looking down here at the bottom, right? So you notice that they're going off towards the right side. So I'm going to point my fingers to the right side. They're going to loop around in a counterclockwise direction, and then my thumb is pointing down. Okay, I can tilt this way. Okay, that's a bit better. Okay. So it's going to loop around this loop like that. Yeah, if I can tilt this way, yeah, there we go. All right, so it's a loop around there. If my thumb points down, that's where the north side of my magnet is. So here's this picture. There's that picture again. So my current is flowing this way and my thumb is pointing down. So my current in this picture, let's see if we can get a different color here for you. My current in this picture is going this way on this wire because I'm looking at the front side of this wire. It's going to loop back around to the back side there, but at this point here, that's the front side. So my current is going to go that way around the front side. My thumb points down. So that thumb points down, points towards the north side of this electromagnet. So we do this, we wrap it around a few times. And if I just put loops upon loops and upon loops, and they're all stacked in the same direction, because of how fields are, the vectors, they're just going to add on to each other. They're just going to, they're all pointing in the same direction. Vector addition says you just add them together, you just get a little more stronger. If they're all pointing inwards, then they add together and get stronger. So here I just created a bunch of loops. So there's a loop right here where it's going around. Here's another loop that's going around. There's another loop that's going around. They're all going in the same direction. It's just spiraling, but it's just a big spiral, but they're all going in the same direction. They all follow the same logic of this picture right here. We have these tiny little loops around those loops for the magnetic field. So this is the current flow. So that's my electron flow. There's going to be, based on my hand rule, it's a bit tricky if I can tilt this the right way. Based on my hand rule, it's going to go this way. So there's going to be a little magnetic field looping around this wire in this direction. Right. That's the magnetic field. Now all of these little are going to do the same thing. Just kind of tricky to sometimes draw this out. This one's going to go like this. Okay. Now they're all going to do the exact same thing. They're all going to loop around. And then you notice that these ones on the top here, they all go in the same direction. So they're all going to add there. The ones that kind of go in towards, they're all going to go in the same direction. They're going to come out this side and loop around, add in, and go this direction here. So based on my hand rule, it's pretty easy. So put my thumb or put my fingers. It's a bit harder to do this with my camera. So I'm going to put my thumb in there. My fingers are going to wrap around the direction the current is flowing here. So you can see the current is going around this. So that's the direction of the current. It's going that direction. Current's going this direction. So my hand is going to wrap around that direction. My thumb, you can see in this picture, my thumb is just going to point towards where the north side of this magnet is. You can see these lines are coming out from that side. And then the other side is just going to be the south. So my thumb points towards the north. This is a solenoid rule. The reason it's called a solenoid is that this is the core, the wires around it. This is called a solenoid when you wrap a wire around something. So one of the solenoid rules, when you have a coil of wire, it's a second-hand rule. So whenever I talk about hand rules, my first hand rule, if I just go back here quickly, determines which way the magnetic field is moving, right, around the wire. Then if I loop that wire around, I create the second hand rule, the solenoid hand rule, which tells me where the north side of the electromagnet is. And there's a third hand rule for the later one. Right? So this just describes exactly what we did. Okay. All right, so this describes exactly what we did here. The second hand rule just says you wrap your fingers around in the direction the electrons are flowing. So you can see in the picture, they're flowing this way around. So that's why my hand here in this picture is wrapped that direction. That's the electron flow. Okay. And then your thumb just points towards the North Pole. This is the magnetic North Pole of the magnet that we have there. Okay. So I'm gonna stop the video at this point. Okay. I'm gonna give you guys, I'm gonna start the next video up. This is technically bell work, so that'll just be the beginning of the next video. But I want you to try these 2 questions out here. Try out the assignment that's linked in with this lesson as well at the very bottom. There might be 2 assignments, I can't remember. But try those assignments out. I'll post the answers. Remember, if you have any questions on those assignments or anything that we've done here, check out the Google Classroom Hangout. For office hours, the physics are going to be in the morning from, like I said, between 10 and 11-ish. I say ish, it's probably going to be about an hour and a half long. If you can't make it to those ones, the math one is in the afternoon from 1 to 2-ish. And I don't know how busy the math one is. You could just log in and say, can I ask a quick physics question? And then if no one else is there, maybe you can get some of my time from that. Okay. So try out these questions, try out the assignment, and I'll get back to you in the next lesson. See you later.